So now we're going to go back to the chain class and we're going to create a method which allows us to add a block to blockchain. And for the method to add a block, we want to first verify that the transaction was valid by verifying it with the sender's public key and the actual signature. And if it is valid, then we can add it to the blockchain. We can do this just underneath the getter method. Let's add a block. Let's scroll down. We want to take in the transaction, which will of course be a transaction object. We want sender's public key. And we want the signature. So the first thing that we want to do is we want to verify this transaction. And we can do that once again using the crypto library. So once again, we're going to use the SHA-256 algorithm. And then we want to update this verifier with the value of the transaction. Now, this verifier will basically return a Boolean when you call the verify method on the public key and the signature. So what we can do is we can just do a check here. We can just check that if, let's just declare it as a variable, is valid. Let's verify whether this transaction is indeed valid. And the way that we can verify it is with the sender's public key and the signature itself. So this will return a Boolean. So then what we can just do is we can just check if this is valid. If it is valid, then we can create a new block, which will of course take the last block as a hash, as one of the parameters in this method, in this class, and the transaction, so that we can actually create the block using this information. And then what we're going to do is we can just push this new block to the chain, if of course it is valid. So now what we've done is we've added the ability for somebody to send money to another user, and then this transaction to be added to blockchain. However, as I mentioned before, there is this concept of mining blocks that we need to consider. And we need a way to validate each transaction on the blockchain. So what we need to do is we need to implement a mining method, which will allow us to validate each of the transactions or each of the blocks on our blockchain. And this mining method will just take one parameter in it. It'll take in that number only used once parameter. So we're going to want to add this mining method within the chain class. Once again, as I mentioned, we just want to take in a number, which is the number only used once as the input. Now let me explain a little bit more about what we're going to do here. So I spoke about finding a solution to the block earlier. And basically what I mean by that is the goal of this mining method is to attempt to find a number that when added to the nonce value of the block, produce a hash that starts with a specified number of zeros. So the number of zeros that we will use is 4. However, in practice, it changes all the time. In fact, the number of zeros today for Bitcoin is actually at 20. And what this means, basically the number of zeros that you're specified to actually find is equivalent to the difficulty of mining one of those blocks. So what you'll see is that on the very early transactions of Bitcoin, there was much fewer zeros that needed to be mined in order to validate a block. Whereas now there's 20. So as Bitcoin becomes more valuable, it becomes more difficult to find a Bitcoin, and therefore the computations to find one of those Bitcoins takes even longer. Now, the thing is here is that there is no real intelligent way of finding the solution to these blocks. It's really very much a brute force method. But when we find a solution, it's then sent to every other miner in the world for them to confirm it as well. So let's start with a solution of 1, and we'll just keep iterating by adding 1 each time until we find a solution. And I'm going to add some logging here as well, just so we can understand a little bit more what's actually going on when we run this blockchain. And for this cryptocurrency, I'm going to call it Turtlecoin, but you can call it whatever you want. So in order to create that infinite loop, we're going to use a while loop. And what we're going to do here is we are going to, first of all, create a hash. And we're going to create a hash using the number only used once value and the solution, i.e. 1. So So the number only used once is the predefined number, which is saved in each block. And the solution is what we have defined up here, which we're going to start with as 1, and we're going to iterate until we find a solution. So let's set up the hashing object using the crypto library once again. And we're going to use a slightly different hashing algorithm here. We're going to use MD5. The reason why is because it's a little bit more lightweight, and it's a little bit faster computation, but it works in a very similar way to the SHA algorithm. And then we're going to update this hash with the value of the number only used once plus the solution. And we're going to convert this to a string like so. So now that we have our hash of our candidate solution, if you like, we can see whether this actually is a solution to the block. What we're going to do is we're going to convert this hash into hexadecimal format so that we can use it as a string. And then, as I mentioned, in order for us to qualify whether we found a solution, we need to find a number which, when added to the nonce and is converted into a hash, produces a certain number of zeros at the front of the string. So what we can do is we can check the front of our string to see whether we have that specified number of zeros. So if tempt dot substring, we want the first 4 values is equal to 4 zeros, then I'm going to log the solution saying that we found a solution to this block, and I'm going to return the solution. If not, then we'll just keep iterating until we find a solution. Okay, so now what we've done is we've added the ability to mine a block on our blockchain in order to confirm that that block is actually valid. So the last thing that I need to add, which will actually finish the main body of our code for this blockchain, is in our chain class in the add block method. So at the moment, if we are happy with the transaction, if we have confirmed that it is a valid transaction, we're simply just creating the block and adding this block to the chain. But before we add the block to the chain, what we want to do is we want to mine it in order to validate it. So we're just going to add this in. So we're going to take the new block and we're going to make use of the number only used once property of it. And we're going to send this to the mine method. So what I've done now is I've just cleaned up the code a little bit, added some comments and added some more logging as well. So that when we run this, we'll know a little bit more about what's going on.